Hey Sydney, I took a look at the work when I got back to my classroom this morning, and I hope you and Landon can kind of work through this and you are ready for your engineering final. So we've got a tube of 0.06 meters in diameter with a velocity of 2.4 and a starting pressure of 160,000. So 1.6 and then add 4 more zeros, so 160,000 pascals. When you get reduced to a lower diameter, we're going to have all this water flowing through a smaller space. So we expect the pressure to go up considerably, but as you know, we need to find the velocity first before we can find the pressure. So using continuity of flow or the area velocity relationship between the two diameter pipes. And I don't think anyone has had any question about the velocity coming out to be 21.6. Landon did that, I think you did, and I agree with that. Now here comes the work, okay? So now we have kind of the Bernoulli's principle, okay? Sort of like we have the energy of the system. Remember, this has a similarity to potential energy. This has a similarity to kinetic energy, but instead of mass, we're using density. And what that allows us to do is to basically convert the units to pressure units. So we've got no change in height, so those are canceled out. So we've got P1 plus 1/2 density times velocity squared. So 1.6 times 10 to the 5th plus 1/2 thousand times 2.4 squared. And this is me checking in with my units to make sure they really do cancel. And I believe the units are going to come out to be kilograms meter per meter second squared. And you were right, there's an extra 8 here. So 160,000 plus 162,880. And I did that out, and you get, what is that? 160,000. The starting pressure, 16 and 4 zeros, plus 162,880. And so the total on the left is 322,880. Now on the right side, we've already examined that. We have an unknown P2. We have this, the density is still 1,000 and this much higher velocity. And what I'm noticing, and I'm gonna double check my work here, half of 1,000, 0.5 times 1,000 times 21.6 squared. And you do get a much larger value, 233,280. But remember, just a minute ago, on the left side of this equation, we had 322,880. So what are we gonna do? We're gonna subtract 233,280, and I don't get a negative number now. I get 322,880 minus 233,280, and I get a pressure of 8.96 times 10 to the 4th pascals. And that makes sense, because when you make the fluid flow faster, it actually creates less pressure, kind of like a narrow pipe along the way. So we started with an initial pressure of 160,000, and now we're down to what, 80, let's look at the calculator, easy to read, 89,600, or 8.96. So it's not negative, and I hope, and again, I'm sorry, I'm just kind of relearning Bernoulli's and applying it quickly. Hope that helps.